We are currently learning rules which will allow us to compute derivatives quickly without having to use the formal definition. In section 3.2, we will learn what are called the product and quotient rules. Our goal is given two differentiable functions, f of x and g of x, to find a formula for the derivative of their product, f times g, and their quotient, f divided by g, in terms of the derivatives of f and g, f prime and g prime. We will start by focusing on products. At first, we might guess that the derivative of f times g is simply f prime times g prime. And while this would be nice, unfortunately, this is not true. To see why this is not true, let's look at the simple example where f of x is x squared and g of x is x cubed. We want to compare the derivative of the product, f times g, with the product of the derivatives, f prime times g prime. First, let's find the derivative of f times g. In this example, that would be the derivative of x squared times x cubed, so the derivative of x to the fifth, which according to our power rule is 5x to the fourth. Now, let's compare with f prime times g prime. In our example, we'll have the derivative of x squared times the derivative of x cubed. By our power rule, this is 2x times 3x squared, which simplifies to 6x cubed. We see that even in this very simple example, we got different answers. And so unfortunately, the derivative of a product is more complicated than we'd initially hoped. Let's state the actual product rule. The derivative of f times g is f times g prime plus g times f prime. In words, we'll say this as the first times the derivative of the second plus the second times the derivative of the first. It's the first function, f of x, times the derivative of the second function, g prime, plus our second function, g, times the derivative of the first function, f prime. We will prove this rule in class, but for the video, we'll focus on seeing this rule in action in a few examples. For our first example, let's find the derivative of the function 4x cubed minus 2x times 5x to the sixth plus 4. According to the product rule, we want the first times the derivative of the second plus the second times the derivative of the first. So we have the first, 4x cubed minus 2x, times the derivative of our second function, which is 30x to the fifth, plus our second function, 5x to the sixth plus 4, times the derivative of the first function, which is 12x squared minus 2. If you wanted to simplify further, you could distribute and collect like terms. We aren't going to worry about simplifying at this stage, so for us, you could stop as soon as you've taken the derivative. Let's do a second example. We want the derivative of 6x to the fourth minus 2x squared times e to the x. According to the product rule, we have the first times the derivative of the second plus the second times the derivative of the first. So that's the first, 6x to the fourth minus 2x squared times the derivative of the second, e to the x, plus the second, e to the x, times the derivative of the first, 24x cubed minus 4x. You can stop right here if you like, but if you wanted to simplify, you'd factor out a 2x e to the x from each term and get this as your final answer. For our final example of the product rule, we have the function 5x to the fifth plus 3 e to the x times 2x to the seventh plus 5. Our derivative then is the first, 5x to the fifth plus 3e to the x, times the derivative of the second, 14x to the sixth, plus the second, 2x to the 7th plus 5, times the derivative of the first, 25x to the 4th, plus 3 e to the x. Now let's switch gears and turn our attention to quotients. Again, it's tempting to guess that the derivative of the quotient f of x divided by g of x might simply be f prime divided by g prime. But this is incorrect as well. To see why, let's consider the example where f of x is x to the 5th and g of x is x squared. We want to compare the derivative of the quotient with the quotient of the derivatives. On one hand, we have the derivative of f divided by g, which in this example is the derivative of x to the 5th divided by x squared, or the derivative of x cubed, which is simply 3x squared. On the other hand, we have the derivative of x to the 5th divided by the derivative of x squared, which is 5x to the 4th divided by 2x, or 5 halves x cubed. We see that we have different answers, and so our quotient rule is going to be more involved than maybe we'd hoped. What is the quotient rule? The derivative of f divided by g is g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. In words, we'll say it's the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So it's the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, all divided by our bottom function squared. For our first example, let's compute the derivative of 3x to the 4th plus 4x divided by 6x cubed minus 7. According to the quotient rule, f prime equals the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So we have the bottom, 6x cubed minus 7, times the derivative of the top, which is 12x cubed plus 4, minus the top, 3x to the 4th plus 4x, times the derivative of the bottom, 18x squared, all over 6x cubed minus 7 squared. For us currently, you could stop right here. This is a perfectly fine answer. But if you wanted to simplify, you would distribute the numerator and collect like terms. What about the derivative of x to the 5th divided by 8x minus e to the x? We want the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So we have the bottom, 8x minus e to the x, times the derivative of the top, 5x to the 4th, minus the top, x to the 5th, times the derivative of the bottom, 8 minus e to the x, all over the bottom, 8x minus e to the x squared. Again, you could stop right here, but if you wanted to simplify, you would distribute and collect like terms. For our final introductory example, let's compute the derivative of e to the x plus 3x to the 4th divided by x to the 5th minus x. We have the bottom, x to the 5th minus x, times the derivative of the top, e to the x plus 12x cubed, minus the top, e to the x plus 3x to the 4th, times the derivative of the bottom, 5x to the 4th minus 1, all over the bottom squared. Great, that's all for our introduction to the product and quotient rules. I look forward to seeing you in class.